Okay, now the next method for the push-pull amplifier is the complementary transistor. Okay, this one is quite simple as well. Now it takes one class B amplifier as Q1 over here, and another class B amplifier which is Q2, but Q1 is NPN. We can see the arrow comes out from the base. Q2 is PNP. You can see the arrow goes into the base. Okay, and there is no transformer to split up the signal, so definitely this the complementary arrangement would actually allow to conduct Q1 and Q2 for positive and negative half cycle respectively. Okay, now if this is a PNP transistor, so it is sensitive to positive polarities both at the collector over here plus, okay, plus VCC, and over here which should be positive. So it means that for NPN, okay, there should be this should be plus the barrier voltage, okay, which is 0.7. Okay, it would conduct, okay, Q1 whenever you apply a positive, okay, polarity or positive signal comes over here. It would make this base emitter junction forward bias. Okay, this is NPN, so the plus VCC is there. So basically for the first half cycle, it's shown over here, Q1 will be conducting and Q2 is switched off. Why Q2 is switched off? Okay, though the negative half cycle, okay, for this positive half cycle when it comes, okay, it finds that this is sensitive to negative polarity. Okay, so basically this is base emitter junction, okay, it would always operate at minus 0.7. okay, so since there is a positive half cycle, so only this one this would more become sensitive. Okay, so it will be conducting Q2, which is NPN in nature. Okay, so its natural effect is that it would never operate for the positive half cycle, so this should be off and switched off, so at the output in the load, okay, we can see, okay, this transistor conduction, so we can see a positive half cycle, okay, over here. Now when during the negative half cycle, okay, this will not conduct, okay, because this is NPN. It cannot find any positive sensitivity over here. So basically if this negative half cycle would find, okay, it would forward by this base emitter junction. Okay, because this becomes a negative for this, okay, which is your PNP transistor. So this would operate and this would conduct, so that, okay, IC goes, the current IE flows there, and basically there is a current in the load which is RL given for the voltage over here. You can see for the negative half cycle. So by combining together Q1 and Q2, we can see this one is for positive the output, so Q1 is conducting. Okay, so, and for the negative, okay, this Q2 is conducting, so basically this will be conducting. Okay, so it means that there is no transformer. Okay, the only disadvantage, you can see that we are having two power supplies, but this is because that we are applying, actually we have two transistors. One is NPN, the other is PNP. So that's why to operate these two, we should have two equal and opposite polarities. Okay, so this is done. Now the next thing is, okay, now looking into the disadvantage, as I was explaining. So basically if you see the disadvantage of push-pull amplifier, that it offers crossover distortion. Now this is the point where we actually identify the real distortion. Now you can see, okay, this was, okay, this is your input waveform shape, right? Okay, this is your output waveform shape for push-pull amplifier. Okay, for okay. So if you see over here now, whenever if I come over here, this is more this part, okay. When over here, if you see, when for the input for the positive half cycle of the input signal, when it goes, okay, over here, when it goes, okay, over here, so basically Q1 is conducting, so Q1 would be conducting, this is Q1, okay, which is conducting, okay. Now it conducts, but only when it overcomes the barrier voltage. This part, this one is 0.7, okay, 0.7 volts, okay. Okay, so it means that, okay, at over here, sorry, if I remove this over here, okay, okay, might it okay, this part, okay. Now from here to here, from here to here, this part, okay, there is no conduction, okay, even for Q1, okay. So not nor Q1 is conducting, nor or neither Q1 is conducting nor Q2 is conducting, so basically there is no conduction, okay. So you can see this is simple non-conducting area, okay. Now, okay, over here, when there is a negative half cycle, so there is I cannot show over here, so I would come over here for a negative half cycle, okay. This one, for when it goes into the negative, remember this negative half cycle starts from here, okay. Now for negative half cycle, okay, this Q2, which is PNP, okay, it would be conducting, okay, this would be conducting, and this is non-conducting, but still you can see for this part you should have, okay, okay, a value of minus 0.7, minus 0.7, you should overcome a value of minus 0.7 to basically what, to make this as a forward junction, this base emitter junction as a forward junction. So if it is not in that mode, so basically there will be no conduction, okay. So it means that whenever it goes beyond minus 0.7, so now then what happens, that Q2 will be conducting, your Q2 will be conducting. So it means for that, for this particular area, for this particular area, your Q2 is off and your Q1 is already off, okay. So it means that basically what happens, that between the, okay, so if we highlight, okay, so it means that for whenever there is the signal is lesser than 0.7, okay, so there is no conduction, and similarly over here, when there is no conduction, when it cannot whenever there is no signal greater than 0 minus 7, okay, for the negative half cycle. So you can see that this is a non-conducting areas, these two areas, and we call this as a crossover distortion, actually crossover distortion. So it means that how we can now this is now the biggest disadvantage, okay. So the solution, the question is, can we remove this crossover distortion, okay. So the answer is that we can actually remove this crossover distortion if we make, okay, if we make what, the Q1 or Q2 over here, this area, and over here Q1 or Q2 in a prior conduction state. So in a prior conduction state, that whenever the signal is present or not, okay, this Q1 and Q2 should be conducting, and it should be overcoming 0.7 barrier voltage, the base emitter junction voltage. So for that purpose, okay, we say that we need to include, okay, this can be done with a voltage divider, okay. So it means that now I need some biasing, a small biasing over here, a small biasing over here, DC biasing over here, so that the amplifier is not in the cutoff state, it is not in the conduction state, and it is in a prior conducting stage. So this is, so by this can be done by a voltage divider and a diode arrangement, and the circuit is known as class B AB amplifier. Thank you.